हेलो स्टूडेंट्स, आज हम क्लास 10 सब्जेक्ट साइंस एंड टेक्नोलॉजी पार्ट 1 चैप्टर 1 ग्रेविटेशन इस चैप्टर का एक्सरसाइज स्टडी करना है। क्वेश्चन 1, स्टडी द एंट्रीज इन द फॉलोइंग टेबल एंड रीराइट देम पुटिंग द कनेक्टेड एटम्स इन अ सिंगल रो। तो यहाँ पर हमें गिवन टेबल में क्वांटिटीज, यूनिट्स एंड प्रॉपर्टीज दी है, उनमें से हमें कनेक्टेड एटम्स कंसीडर करके टेबल रीराइट करना है। आंसर, फर्स्ट रो मास किलोग्राम, मेजर ऑफ इनर्शिया। सेकेंड रो वेट न्यूटन, 0 एट द सेंटर। थर्ड रो एक्सेलरेशन ड्यू टू ग्रेविटी, मीटर पर सेकेंड स्क्वायर, depends on height. Fourth row, gravitational constant, Newton meter square per kilogram square, same in the entire universe. Question 2, answer the following questions. A, what is the difference between mass and weight of an object? Will the mass and weight of an object on the earth be same as their values on Mars? Why? इस क्वेश्चन का आंसर हम दो पार्ट्स में लिखेंगे। आंसर, पार्ट 1 मास वेट। 1, द मास इज द अमाउंट ऑफ मैटर प्रेजेंट इन एन ऑब्जेक्ट। नंबर 1, द वेट इज द फोर्स विथ विच द अर्थ attracts an object. 2, it is a scalar quantity. 2, it is a vector quantity. 3, it does not change from place to place. 3, it changes from place to place. 4, it can never be 0. 4, it is 0 at the center of the earth. 5, its SI unit is kilogram. 5, its SI unit is Newton. Second part of answer, 1, mass is a fundamental quantity whose value remains same anywhere. Hence, the mass of an object on Earth will be same as its value on Mars. 2, weight of an object is product of mass and gravitational acceleration, that is W is equal to F is equal to mg. 3, as the weight depends on the value of acceleration due to gravity, that is g, which changes from place to place and is different for Earth and Mars, the weight of the object on Earth will be different than its value on Mars. B, what are 1, free fall, 2, acceleration due to gravity, 3, escape velocity, 4, centripetal force? Answer, 1, free fall. The motion of any object under the influence of the force of gravity alone is called as free fall. 2, acceleration due to gravity. The acceleration produced in a body due to the gravitational force of the earth is called acceleration due to gravity. 3, escape velocity. When a body is thrown vertically upward from the surface of the earth, the minimum initial velocity of the body for which the body is able to overcome the downward pull by the earth and can escape the earth forever is called the escape velocity. 4, centripetal force. The force acting on any object moving in a circle and directed towards the center of the circle is called as centripetal force. C, write the 3 laws given by Kepler. How did they help Newton to arrive at the inverse square law of gravity? Answer 1. Kepler's first law. The orbit of a planet is an ellipse with the sun at one of the foci. 2. Kepler's second law. The line joining the planet and the sun sweeps equal area in equal intervals of time. 3. Kepler's third law. The square of orbital period of revolution of a planet around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Derivation of inverse square law of gravity with the help of Kepler's third law. 1. The centripetal force acting on a planet of mass m and velocity v revolving at a distance of r from the sun is given as F is equal to mv square upon r. Equation 1. 2. Let t be the period of revolution of the planet and 2 pi r be the distance travelled by the planet in one revolution. Then the speed of the planet is given as speed v is equal to distance travelled upon time taken, that is equal to 2 pi r upon t. Equation 2. 3. Substituting equation 2 in equation 1, we get F is equal to m in bracket 2 pi r upon t bracket square upon r, and that is equal to 4m pi square r upon t square. 4. Multiplying and dividing by r square, we get F is equal to 4m pi square r cube divided by r square t square, that is equal to 4m pi square upon r square in bracket r cube upon t square. Equation 3. 5. But according to Kepler's third law, t square is directly proportional to r cube, and therefore t square upon r cube is equal to constant k. Equation 4. Substituting equation 4 in 3, we get F is equal to 4m pi square upon r square k, but 4m pi square upon k is equal to constant, and therefore we get F is inversely proportional to r square. Thus, with the help of Kepler's third law, Newton concluded that the centripetal force acting on the planet must be inversely proportional to the square of the distance between the planet and the sun, and hence postulated the inverse square law of gravitation. Question 4. A stone thrown vertically upwards with initial velocity u reaches a height h before coming down. Show that the time taken to go up is same as the time taken to come down. Answer. In figure, t1 is the time of upward journey and t2 is the time of downward journey. Answer. We know v is equal to u plus at, equation 1, and s is equal to ut plus half at square, equation 2. From equation 1 and 2, we get s is equal to v minus at into t plus half at square, that is equal to vt minus at square plus half at square, and therefore s is equal to vt minus half at square, equation 3. As the stone moves upward from A to B, s is equal to ab is equal to h and t is equal to t1, a is equal to minus g and v is equal to 0. Therefore, from equation 3, we get h is equal to 0 minus half in bracket minus g into t1 square, and therefore h is equal to half g t1 square, equation 4. As the stone moves downward from B to A, S is equal to BA is equal to H, T is equal to T2, A is equal to G, and U is equal to 0. Therefore, from equation 2, we get H is equal to 0 plus half G T2 square, and therefore H is equal to half G T2 square, equation 5. From equation 4 and 5, we get half G T1 square is equal to half G T2 square, and therefore cancelling same part on both sides, we get T1 square equal to T2 square, and then after by square roots, we get T1 equal to T2. Hence, the time taken by the stone to go off is same as time taken to come down. E. If the value of G suddenly becomes twice its value, it will become 2 times more difficult to pull a heavy object along the floor. Why? Answer. The weight of the body is defined as the force with which earth attracts the object. 2. It is given by the formula F is equal to W is equal to mg. 3. From the formula, it is clear that weight of an object is directly proportional to the mass of the object and gravitational acceleration, that is g. 4. Therefore, if the value of g becomes twice, then the weight of the object also becomes twice, and thus it will be 2 times more difficult to pull the object along the floor. Question 3. Explain why the value of g is 0 at the center of the earth. Answer. 1. The acceleration due to gravity, that is g, on earth's surface is given as g equal to gm upon r square. That means the value of the g depends on the mass of the earth and the radius r of the earth. 2. As we go inside the earth, our distance from the center of the earth decreases and no longer remains equal to the radius of the earth, that is r. 3. Along with the distance, the part of the earth which contributes towards the gravitational force felt also decreases, decreasing the value of m. 4. Due to combined result of change in radius and mass, value of g becomes 0 at the center of the earth. Question 4. Let the period of revolution of a planet at a distance r from a star be t. Prove that if it was at a distance of 2r from the star, its period of revolution will be under root 8t. Answer. 1. According to Kepler's third law, we get t square is directly proportional to r cube, and therefore t square equal to k r cube, equation 1, where k is constant. 2. When the planet is at a distance of 2r from the star, then its period of revolution t dash will be t dash square is directly proportional to 2r cube, and therefore t dash square is equal to k into 2r cube, equation 2, k is constant. Dividing equation 1 and 2, we get t square upon t dash square is equal to r cube upon 2r cube, and therefore t square upon t dash square equal to 1 upon 8. Then after taking square roots on both sides, first we get t upon t dash equal to 1 upon under root 8, and then after making cross multiplication, we get t dash is equal to under root 8t. Thus, for a planet at a distance of 2r from the star, its period of revolution will be under root 8 t. Question for you. Solve the following examples. A. An object takes 5 seconds to reach the ground from a height of 5 meter on a planet. What is the value of g on that planet? Answer. Given time t is equal to 5 seconds, height s equal to 5 meter. To find value of g. Solution. S equal to ut plus half gt square. Therefore, 5 is equal to 0 into 5 plus half g into 5 square. And therefore, 5 is equal to half g into 25. And then after 5 into 2 upon 25 is equal to g. And therefore, g is equal to 2 upon 5. Finally, g is equal to 0.4 meter per second square. And therefore, the value of g on the planet is 0.4 meter per second square. B. The radius of planet A is half the radius of planet B. If the mass of planet A is ma, what must be the mass of planet B so that the value of g on planet B is half that of its value on planet A? Answer. Given for planet A, mass is equal to ma, radius is equal to ra, acceleration is equal to ga. For planet B, mass is equal to mb, radius is equal to rb, acceleration is equal to gb. To find mass of planet B, that is mb. Solution. Ra is equal to half of rb. Given. Therefore, we get Ra upon Rb is equal to half. Equation number 1. Also, Gb is equal to half of Ga. This is also given. And therefore, we get Gb upon Ga is equal to half. Equation number 2. Now, we know G is equal to Gm upon R square. Therefore, for planet A, we get Ga is equal to Gma upon Ra square. Equation 3. For planet B, we get Gb is equal to Gmb upon Rb square. Equation number 4. Now, dividing equation 4 by equation 3, we get Gb upon Ga is equal to Gmb upon Rb square divided by Gma upon Ra square. That is equal to Gmb upon Rb square into Ra square upon Gma. That is equal to Mb upon Ma into Ra square upon Rb square. And therefore, Gb upon Ga is equal to Mb upon Ma into bracket Ra upon Rb whole square. And therefore, 1 by 2 is equal to Mb upon Ma into 1 by 2 whole square from equation 1 and 2. Therefore, 1 by 2 is equal to Mb upon Ma into 1 by 4. Then after by making cross multiplication, we get 2Mb is equal to 4Ma. And therefore, Mb is equal to 2Ma. And therefore, the mass of planet B is 2 times the mass of planet A. C. The mass and weight of an object on Earth are 5 kg and 49 Newton respectively. What will be their values on the moon? Assume that the acceleration due to gravity on the moon is 1 by 6th of that on the Earth. Answer. Given mass on Earth equal to 5 kg, weight on Earth is equal to 49 Newton, Gm is equal to 1 by 6th of Ge, that is Gm upon Ge is equal to 1 by 6. To find number 1, mass on moon. Second, weight on moon. Solution. First, mass on moon is equal to mass on earth, and therefore mass on moon is equal to 5 kg, because mass on earth is given 5 kg. Second answer, W is equal to mg. Therefore, weight on moon is equal to mgm, equation 1, and weight on earth is equal to mge, equation 2. Dividing equation 1 by equation 2, we get weight on moon divided by weight on earth is equal to mgm upon mge, and that is equal to gm upon ge, and therefore weight on moon upon 49 is equal to 1 by 6 using given values, and therefore weight on moon is equal to 49 upon 6, and therefore weight on moon is equal to 8.167 Newton, and finally we can write weight on moon is equal to 8.167 Newton. D. An object thrown vertically upwards reaches a height of 500 meter. What was its initial velocity? How long will the object take to come back to the earth? Assume g equal to 10 meter per second square. Answer. Given height s equal to 500 meter, g equal to 10 meter per second square. To find first initial velocity, that is u. Second, total time taken. Solution. First answer. For upward journey, v is equal to 0, a is equal to minus g, that is equal to minus 10 meter per second square, and formula is v square equal to u square plus 2as. Therefore 0 equal to u square plus 2 into minus 10 into 500. Therefore 0 equal to u square minus 10,000, and therefore u square equal to 10,000, and taking square roots we get u is equal to 100 meter per second, and therefore initial velocity u equal to 100 meter per second. Second answer. For downward journey, u is equal to 0, a is equal to g is equal to 10 meter per second square, and formula s is equal to ut plus half at square. Therefore substituting given values, 500 is equal to 0 plus half into bracket 10 t square, and therefore 500 is equal to 5t square. Therefore t square equal to 500 upon 5, that is equal to 100, and taking square roots on both sides we get t is equal to 10 second. Now time for upward journey is equal to time for downward journey, that is equal to 10 second, and therefore total time taken to go upward and come down is equal to 10 second plus 10 second, that is equal to 20 second, and therefore total time is equal to 20 second. E. A ball falls off a table and reaches the ground in 1 second. Assuming g is equal to 10 meter per square, calculate its speed on reaching the ground and the height of the table. Answer. Given initial velocity u equal to 0, g is equal to a is equal to 10 meter per second square, time t is equal to 1 second. To find first height, that is s, second velocity, that is v. Solution. First answer. Formula is s is equal to ut plus half at square. Substituting given values we get s is equal to 0 plus half into 10 into 1 square, and therefore s is equal to 10 by 2, that is equal to 5 meter, and therefore height of the table s is equal to 5 meter. Second answer. Formula is v square is equal to u square plus 2as. Therefore, substituting given values, v square equal to 0 plus 2 into 10 into 5. Therefore, v square equal to 100, and therefore taking square roots, v is equal to 10 meter per second. And therefore, velocity of the ball on reaching the ground is 10 meter per second. F. The masses of the earth and moon are 6 into 10 raised to 24 kilogram and 7.4 into 10 raised to 22 kilogram respectively. The distance between them is 3.84 into 10 raised to 5 kilogram. Calculate the gravitational force of attraction between the two. Use G is equal to 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Answer. Given mass of earth, that is m1, equal to 6 into 10 raised to 24 kilogram. Mass of moon, that is m2, is equal to 7.4 into 10 raised to 22 kilogram. Distance r is equal to 3.84 into 10 raised to 5 kilometer. That is, distance r is equal to 3.84 into 10 raised to 8 मीटर. तो किलोमीटर को मीटर में यहां पर हमने कन्वर्ट कर लिया. एंड g इज इक्वल टू 6.7 इंटू 10 रेज टू माइनस 11 न्यूटन मीटर स्क्वायर पर किलोग्राम स्क्वायर. एंड वी हैव टू फाइंड ग्रेविटेशनल फोर्स, दैट इज F. Solution. We know F is equal to g m1 m2 upon r square, and therefore F is equal to value of g, that is 6.7 into 10 raised to minus 11 into value of m1, that is 6 into 10 raised to 24 into value of m2, that is 7.4 into 10 raised to 22 upon value of r, that is 3.84 into 10 raised to 8 whole square. That is equal to 6.7 into 6 into 7.4 divided by 3.84 into 3.84 into 10 raised to 19. After further calculation, finally we get F is equal to 2 into 10 raised to 20 Newton. And therefore, the gravitational force between Earth and Moon is 2 into 10 raised to 20 Newton. G. The mass of the Earth is 6 into 10 raised to 24 kilogram. The distance between the Earth and the Sun is 1.5 into 10 raised to 11 meter. If the gravitational force between the two is 3.5 into 10 raised to 22 Newton, what is the mass of the Sun? Use G is equal to 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Answer. Given mass of Earth, that is m1, equal to 6 into 10 raised to 24 kilogram. Distance r is equal to 1.5 into 10 raised to 11 meter. Gravitational force, that is F, is equal to 3.5 into 10 raised to 22 Newton. Gravitational constant G is equal to 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. And we have to find mass of the Sun, that is m2. Solution. We know F is equal to g m1 m2 upon r square. Here we have to find mass of Sun, that is m2, and therefore we will rearrange this formula as m2 is equal to fr square upon g m1, that is equal to value of F 3.5 into 10 raised to 22 into value of R 1.5 into 10 raised to 11 whole square upon value of G, that is 6.7 into 10 raised to minus 11 into value of M1, that is 6 into 10 raised to 24. After further calculations, we get M2 is equal to 1.96 into 10 raised to 30 Newton, and therefore mass of the Sun is 1.96 into 10 raised to 30 न्यूटन। स्टूडेंट्स, इसके साथ ही हमारा ग्रेविटेशन चैप्टर का एक्सरसाइज कंप्लीट हुआ। थैंक यू।